So what do we discuss now about the difference between Ansible and Terraform, right? As I said, Ansible is mostly used for configuration management and continuous deployment, though it has capacity or capability to do the infrastructure as code or to do the infrastructure automations, but it is specifically being used by all the companies as configuration management and continuous deployment tool. Whereas the Terraform is specifically being used for infrastructure automation. And that is why it's called infrastructure as tool or ISC tool, okay? Infrastructure as code or ISC. So let's see in detail what is ISC, and then we'll talk about the Terraform, okay? So what is ISC? The code ISC is the managing and provisioning of infrastructure through code instead of through manual process. So whoever has little ideas on writing or creating the server, storage and all. So I hope like everyone would have at least little ideas on creating servers or something in the AWS cloud, right? I already have shown you multiple times in our last classes, right? Previous classes, whenever I used to create the servers, EC2 instances, right? We already have seen how manually we select those required options and create it, right? But when we talk about the automations, when you talk about the organizations, right? That time we don't have to manually go and select those required options to create the server. So what we have to do, we have to use some sort of tool to automatically create those stuffs for us, right? So that is called as infrastructure as code. So it manages and provision the infrastructure through the code. So with ISC, configuration files are created that contain your infrastructure specifications, right? Like we have written our Docker file, right? What the Docker file contains, it's a template, right? It contains the instructions for the image to be created and for the container which is required to run. What sort of specification is required, right? We have to put all this together, right? So which makes it easier to edit and distribute configurations. It also ensures that you provision the same environment every time without any mistake. You have written some sort of specification, some sort of code to create a server. You have written that we need that particular EC2 instances, that particular network BPC, and that particular storage, that particular volume. All these things you have all specifications. You have written the infrastructure file, the code file, right? Whenever you execute that, that will create same specification all the time for you, right? All the time for you, right? So if someone go and create it manually, so what will happen? There could be a chance of misselecting something differently, and it will cause the problem to the environment, the system, right? So that's why it also ensures that you provision the same environment every time whenever you need it. Automating infrastructure provisioning with ISC means that developers don't need to manually provision and manage servers, operating system, storage, and other infrastructure components each time they develop or deploy an application, right? So when you need these things, whenever you are going to create a new server and for your development team, for your testing team, and for your productions also, right? So that time you can just choose Terraform to completely automate. So in the market, right, why it is so popular and why it is being rapidly used? It's because all the companies nowadays, they are moving their on-premises infrastructure to the cloud one, right? To the cloud infrastructure. That is why for the entire automation stops, right? While entire infrastructure, if they are trying to move from on-premises to the cloud, they need some sort of automations to perform that, right? Because if you do manually one by one, it will take lots of time, lots of resources, and chances of mistake also there, right? So that's why they are going with the Terraform, and lots of requirement in the market. So you'll be thinking, once a server is created, no companies are going to create the server every time, right? Whenever there is a requirement, hardly when a new project comes or something new server is required for a team, hardly once or twice we have to write it. So once it is done, then there will be no requirement, right? Very, very rare requirement will be there. But nowadays, as everyone moving towards the cloud and they are just migrating their infrastructure, we need this Terraform to automate them. Okay? One second, guys. So what is Terraform? So we talk about the infrastructure, then let's see what is the Terraform. Terraform is an infrastructure as code tool. It's called ISC tool that allows you to build, change, and version infrastructure safely and efficiently. It is a tool for building, changing, and managing infrastructure in a safe and a repeatable way. What is we are talking about just before, right? So it manages the environments with a configuration language called HCL. It's called HCL, is called Hashicorp Configuration Language. Hashicorp Configuration Language. Okay, so we can automate our infrastructure creation and provisioning using the Terraform. That is why the Terraform is being used for. Okay, so let's see what are the details and the more support is being used. And there is a website, the documentation official website that you can use. That's called terraform.io. Terraform.io. Automate infrastructure on any cloud with Terraform. On any cloud with Terraform. We'll see how we can just use this Terraform with different cloud infrastructure. Okay, so here we have the overview, you have the use cases, documents are there to read out, right? We'll just go through most of them in a short period of time. Okay, so let's see, it supports multiple platforms. It has hundreds of providers. We'll see what these providers, don't worry about this term, whatever we are just listening. And it is simple configuration language and faster learning curve. This is very simple, guys. As I said, we would have seen, right, whatever the tools we have covered so far with respect to Jenkins, Docker, with our Kubernetes, Ansible, they all have different way of writing the code, right? Jenkins has a Jenkins file. We know how to write the pipeline script. Docker, we know how to write the Docker file, Docker instructions. Kubernetes, how we write the specifications or Kubernetes, that configurations file, YAML file. Similarly, how we can write the playbook in Ansible. And here in Terraform, it's a very simple way to write the code also. It has different DSL, right? Domain-specific language, and it's using HCL, Hashicorp configuration language. It's a very simple way to learn. That's why it says it's simple configuration language and faster learning. You can easily learn it. Easy integrations with configuration management tools like Ansible, easily extensible with help of plugins. It's free. Most thing is it's open source. Okay, so when you talk about these providers, what is the providers actually? Okay, before moving to the providers, let's talk about the ISC tools available in the market. So there are various types of ISC tools. One is called Terraform, which is the highly demanded market. Another one is the Cloud Formation. Okay, this is actually AWS product. Okay, AWS CloudFormation. So using this CloudFormation, this is native to the CloudFormation. So you'll be saying like, if CloudFormation is there, then why should we go with Terraform? We can use CloudFormation with AWS, which will be easy because it is native to AWS, right? Why should we go for Terraform then? Because CloudFormation is specifically designed for AWS, but Terraform can work on hundreds of multiple other cloud providers. Not only with AWS, if you're tomorrow learning Google Cloud or Azure Cloud, you can still use Terraform to automate the cloud environment. Okay, now Heat, Ansible. See, Ansible also one of the ISC too. It also, as I said, it also has capability of doing the infrastructure automations. Salt Stack, Safe, Puppet, etc. These are the tools, but Terraform is highly demanded. So configuration management versus infrastructure orchestration. So Ansible, Safe, Puppet are configuration management tools, which means that they are primarily designed to install and manage software on existing servers. Okay, they are primarily designed to install and manage software on existing servers. Terraform and CloudFormation are the infrastructure automation tools. Terraform and CloudFormation are the infrastructure automation tools, which basically means they can provision the servers and infrastructures. This is two major difference with Ansible and Terraform. Okay, let's see the diagram here, how it is being worked. So first, what you have to do, you have to just write a Terraform file. Okay, and suppose you are going to create a new server and just write the file name, any name with .tf extension, .tf. Then using Terraform, when you execute the command, that will create new instances on any particular server. It could be AWS or Google or Azure, whatever. So it creates new server, and then what happens? After it creates the server, you can use Ansible to configure and deploy the applications. So this is the integrations we can do it. Now, what do you do? If you see this, okay, anyway, we have a project, and this project will just explain the later page to write the code, how we can achieve this, whatever is there in the diagram. Okay. Now, let's talk about the installation process, how we can do the installation. Okay. It's very simple, guys. This installation process I will leave to you, so you can just simply go ahead and do the installations. You just follow the documentations here for the installation. See, it just gives download open source, right? Click on this download open source, and here it gives the complete details how we can install the Terraform. If you're using Mac OS, you can just use brew command, brew package manager, to install the HASIC of Terraform. So on my Mac machine, I already have used this command to install the Terraform, right? So let me just open terminal here. So if I just do Terraform here, you can see I get the response back here, right? So if I just use Terraform, version, it gives us the which version of Terraform I have. So this is a procedure on Terraform version 1.4.6. So your version of Terraform is out of date. The latest version is 1.5.4. So we can download and use to do that. So this is after installations, you can use Terraform version to make sure that you have installed appropriate Terraform on your system. So for Windows, you can download the zip file and extract it and use it there. Okay. And for Linux, it has also same zip file. You can download it. Okay, this package, and then you can install Terraform. Some key you have to just download it. Okay, see, and then you can install it. And for other platforms, based on your requirement, you can choose it and install it. It can work from any operating systems. Okay, now, so this installations part, as I said, is very easy. Just few commands you have to just add it. If you are using Linux, just use this one and make sure that this is apt and this is for Ubuntu, right? This is for Ubuntu we use. And for different platforms, you can just use simply download this and just use yum package manager to install the Terraform. Okay, so it has the latest version. If you want to choose any other versions of that, so you can go ahead and select what particular versions you need. Okay, for here 1.0 to 1.5, the latest version. So I have this 1.4 version, right? 1.4.6. So guys, hope you guys will install this one. I'm not going to show you the installations. I have already installed on my Mac machine. I'm going to show you on this. Okay. So as I said, this Terraform version is there. Okay. What we can do, let's go ahead and create. Let me just search if I have any Terraform folder created. Just a file. Okay, not here. Just go to the desktop here. Let me search if I have any documents created here. Geez. What is different? Good. Nothing is there. That's fine. So what we can do now, let's first create a directory. There we'll just write all our projects, all our code, whatever we are going to do the demo in this class, everything I'm going to put it here, right? So let me just name it as Terraform batch name B8. Okay, Terraform B8. So I have created a folder. Let's move into that folder. Okay, good. So what we can do before doing that, once we have installed everything, just create a folder. Before that, let's see what else about the Terraform and how we can use it. And we need to learn about the provider I was talking about, right? That we must learn about that. So let's go ahead. So installations is a task for you. Do installations after this class. Okay. Not this one. Okay. I was talking about the provider, right? What is the providers? That is the most important actually in Terraform. You need to understand the providers first. So here we're talking about the providers, right? Where so somewhere, right? The providers.
Yeah, slide number 5.
Yes.
First point, right?
So the supports multiple platforms. It has hundreds of providers. So what is this providers? The providers, let's go ahead and see. Providers allow Terraform to interact with cloud providers like SaaS providers or other APIs. So Terraform supports multiple providers. Depending on what type of infrastructure we want to launch, we have to choose the appropriate providers. So when you talk about the provider, what exactly it is actually a plugin. It is actually a program of specific service providers. So the service providers, they're giving a name as provider. It's a service provider like AWS, Azure, Google Cloud. Okay. So they provide their plugins to Terraform to use to create the infrastructure. So that's called the providers. Okay. So if I just go to this particular terraform.io, you'll find here registry, right? So documents related to that, you can go ahead and click this one, and you'll find the complete documents based on your learning skills. I'll just go through everything. Don't worry about at all now. Now, it has one tab called registry. Go to this registry, and you'll find, see here, Terraform registry. We're going to see about the modules. We are going to see about the providers and everything. Okay, just hold on. So let's first talk about the providers. Click on this browse providers. See, these are what it says. Providers are a logical abstractions of an upstream API. They're responsible of understanding API interactions and exposing the resources. So these providers being provided by the respective cloud provider, providers or service providers in order to use in Terraform to automate their infrastructure. So AWS, Azure, Google Cloud, Kubernetes, Alibaba, Oracle Cloud, right? Similarly, it has hundreds of or thousands of other service providers. Like see Active Directory, Azure Directories, you can use, right? See here, partner providers. We have here, it has 69 pages. 69 pages of providers. See, these are completely providers, whatever they provide. Suppose you want to search something, right? You want, suppose, to work with Docker, search for Docker. We have this, see, this particular Docker, this partner provides a Docker. It's actually kind of module, kind of plugins, right? A program. If you are working on the Artifactory, you can find the JFrog Artifactory. If you are working for Nexus, right? Setting up the Nexus, if you search for Nexus, you'll find someone providing the Nexus here, resources. So here is the provider stuff, okay? Now, how you use these providers, right? Suppose what we are going to do, we are going to work on the AWS. Okay, suppose you need GitHub. Using Terraform also, you can create your repository, create the account, you can work on your GitHub account also. You don't have to go and create repository manually. Using GitHub also, if I just search for GitHub, right, we'll find the GitHub Git. You'll find the GitHub providers also. Okay. So now here, if you just go here, let's go with AWS. Okay, click on this AWS provider here. So what it says, AWS provider, and it is official, and it is being created, maintained by HashiCorp. This particular plugin, this particular program is created by HashiCorp itself. Okay, but if you see here, other, if you choose, this is provided by HashiCorp, this is provided, these all are provided by HashiCorp. So if I just go a little back here, partner providers, right? Partner providers. If you just see for this particular, let's go with this JFrog, okay? Artifactory. If you see here, it just gives a partner. That means that is being provided by JFrog. This is this particular plugin, this particular provider provided by JFrog. But if you talk about the AWS, it is being provided by HashiCorp itself. HashiCorp Terraform is the HashiCorp's product. HashiCorp is the company who has designed and developed the Terraform. So they have also created this program and this module, this plugin provider being used to automate the infrastructure. Okay, clear? Now, how to use this provider? You can see here, you can just go with the documentations. I'll go with that later on, but let's go with the providers, how to use it. If I just click it, you can simply see the provider details. Okay, provider details. Now, how you will write the code to automate the infrastructure. As I always tell you guys, whenever you do any coding, any automations for any specific tools you are learning, you have to focus on the documentation. You have to see the documentation, how they have written, and you have to follow their documentation to write some similar kind of quality code, right? So if I just go, suppose, let's see a small requirement here. Let me just explain you. Suppose I want to create a small server, one EC2 instance, okay, with T2 micro, one EC2 instances with T2 micro. So what I need first, I talk about, suppose when we talk about the EC2 instances, then EC2 instances is part of the AWS. Then what I should use? I should use AWS provider. Suppose you are going to create Azure machine, right? Azure virtual machine. Then you should go with the Azure provider, right? So this is the provider details, how you can use the provider. Suppose here AWS, suppose if I choose Azure, it will have different way of writing. So if I just go here, see the provider is given Azure RM. Azure RM is the provider name, and it is the required provider Azure RM. Let me explain you in details. Let me explain you in details about the provider, how you'll use these providers. Okay. Now let's go ahead and create one. Just create one provider block and to use how we can and see how we can use it. Okay. So if you see here, the simple provider configurations, whatever I've written here, I just have written the provider block here, but I just showed you how we can get it from the documentations, right? I'm not going to use that one. So let's copy this one particularly. Copy this one. Okay. What you can do, go ahead, create, suppose I just want to create a server, right? Just give any name. I can just give EC2 instance. EC2 instance dot TF. Any name, okay? But it should have ended with .tf extensions. Hit enter. Now paste the provider block here. Okay. So what I did, let me just explain you. So here I'm just using the Terraform block. In this Terraform block, you have to use this required underscore providers. Required providers, why we need? What particular versions of providers do you need to use? Suppose you have, if you are going with some specific version of Terraform, then you have to choose this required provider block. Otherwise, it will not. If you don't mention this particular part, it will absolutely fine. It will absolutely work. But the problem will be, it will install the latest version of the Terraform, which will not be required in your case, which may be not required in your case, right? So you have to be specific which particular version you need to use. So here I'm just given the source is HashiCorp AWS. That is means it's maintained by HashiCorp, right? Created by HashiCorp. So it's given HashiCorp AWS. Version, which particular version of this AWS program or module or plugin or provider, particular version of provider you're using, you have to give it here. And you have to use another provider block, AWS, and this is required for the configurations to set up here. So what are the configurations? Let's see how I'll write these configurations. Let's go to this documentation now. Now this is very simple. We got little details about how to use it. The provider. Now let's go to the documentations. Before that, if I just go here, it has few modules here. How to use this module sections, we have this advanced sections. I'll talk about later. Then we'll come here and use it. Okay. Now let's go to the documentations. Okay. See, here is the things. You can get everything, all syntax. You have to get it from here, and you have to learn from here itself. Okay, the documentations, and you have AWS provider. Just go below. You can see here how you have written it. Now, here's a simple example. Here it is very simple. Example is being given here. Okay, very simple example. Now, if I just see it here, the one I had shown you is given version particular 5.11.0. But if you see here, I have given here, it is given the version tilde symbol less than 5.0. Means it will use this particular providers which is less than or equal 5.0. If more, see, if 5.1 or 5.2, it will not use it. Below 5.0 or 5.0, it will install the provider, download the provider and use it. If you don't specify it, what will happen? It will just use this 5.0 version. So the 5.0 below whatever the plugins, it will be used. But normally in your organizations, you have to be specific. You have to be specific. Means suppose you are using 4.6 version, 4.6.0 means you have to specify 4.6.0. Otherwise, it will break the code. Okay. Now, here is the provider block. What you have to use it, right? Here, the region, right? Now let's go ahead. Here I'll the code. Now, here is the region equal to this one, access key, secret key, and all this, right? Let's copy this particular part, right? Let's go ahead and copy this particular part. Let's go to your code here. And what I need this to be added here. Okay. I need this to be added here. Sorry. I don't need extra this one. Let's delete this particular one. Okay. So the provider, AWS, region, this one, and access key. So what is this region you have to provide? This region is nothing but your which particular AWS region you want your resources to be created, want your server to be created, right? So you have to specify that. So here we have copied US West 2, which is nothing but your US West 2 will be, if I just go here and go to the region section, US West 2 is US West Oregon. It's an Oregon region. For India, for Asia Pacific Mumbai, then you have to use App South 1. Any region you want to use it, right? Any region you want to use to create and automate your infrastructure, you have to choose accordingly. Suppose you want to go with Singapore, right? Asia Pacific Singapore, then you have to use App Southeast 1. Let's go with App South 1. So what I'll do here, I'll write the code. Let's delete this particular thing. Mention here AP South -1. Okay. Now I just use it. Now what I need, I selected which region I need to connect and create the infrastructure. But same time, I need the credentials to connect the server, right? To connect the AWS account. So I have to provide this access key and secret key. Can anybody tell me from where I can get this access key and secret key?
From IAM.
From IAM.
Yes, from the IAM, I can get this access key and secret key. For that, what we have to do, we have to just create one IAM user, right? Let's go ahead and create one. I'll quickly go ahead. So Joycelyn, for you, just have a look how we can create users IAM, but I'll take separate cloud classes for you with different batches that I'm going to take it. Okay, don't worry about that. Let's go to the
Okay.
IAM here. Select the IAM. IAM is nothing but your identity access management. Okay. Click on this IAM here. Right. And go to the here. You can see here I have one group, one users, and two roles. Let's go to the user sections and go ahead and create one user. Suppose I go add user, give one user like TF demo, something like this. Next, add user to a group. First, so I have suppose KHS group administrator access. Let's go ahead. Next, create user. Simply I added the KHS group. Okay, our TF demo is created. Now, how will get the access key and all? Let's select this one. Okay. Now, if I just go to the security credential, so permission level, it has administrator access. Okay. Go to the credential, security credentials. And here, what you have to do, access key, right? We have to create one access key. Create access key here. And what sort of things you need to connect to the server? So you can use command line interface if you are using command line interface, or application running on AWS services, third-party services, application running on outside AWS, right? So you can choose any one of these. So if you're planning to use access key to enable AWS CLI, access to your AWS account, local code, if you plan to use this access key to enable application code in local development environment to access your AWS account, so let's go ahead with local code. Okay. And I understand the above recommendations. And let's go ahead and click on next. Okay. And just give a description tag, otherwise create access key. So you can see here, when I just clicked on, it gives us the access key here and the secret access key. See, copy this one, right? Go to here and put here the access key. Okay. And similar, you have to put here also the copy this particular one. And similarly here, you have to put this secret key also. So access key and secret key, we put it here, right? Simple. Done. Now, so you can see here, guys, it is not actually a good way of giving the access key and secret key in the code itself. Because if someone finds this one, it can misuse the code, right? So I'll show you also how we can hide these informations in a secure way. We don't have to put all this access key and secret key in our Terraform code. Okay, how we'll hide it? It has also, if I just go to the documentations, right, in the Terraform, it gives all the ways other settings related to authorization can be configured. We can set up in profile, shared configurations file, right, shared configuration. So see, this is the way it's given completely how we can store it and how after storing, how we can use it. Okay, I'll give you a simplest way. All these things, whatever is given here, I'll just explain you in detail. Okay, but the time being, let it be in the plain text and let's see how it is. Now, we used this provider block. That means we are going to use this particular AWS provider to automate the infrastructure or provision something from this particular region using this account, using this user account. Now you are clear with, right? Now let's go ahead. So we have set up the account, we have set up the plugin, what we need, we have set up the providers, right? We have set up the access key, user account, everything. Now we need what you need to create. We got all the keys, right? So when you go to a hotel room, you got the keys, right, to access the hotel room, but you should know which room you have to go and open, right? Or we, in simple ways, if you have created one infrastructure, you should know what service you are going to use it. Now you need the resource, which particular resource you have to create. So if I just go ahead and create a resource, then we have a resource block. This is a provider block, then we have a resource block. So how we'll use the resource block? Here, if you can see here, we have all the resources available for AWS provider. These are the resources. These are the resources provided for AWS block. These are the resources provided for. Suppose I want what I need. I want this provider details. We got it now. Now I need the resource details, right? So suppose here, sorry. So what I need suppose EC2 instances to be created, right? Suppose I'll just go with EC2 instances, right? See, EC2. What is the Elastic Compute Cloud? Elastic Compute Cloud, right? So what do you do? Select this EC2. Okay, so you have to select this EC2 Elastic Compute Cloud, right? So select this one. Now, see, we have this resource block, right? Let's minimize. We have this resource block, and same time we have this data source block also. We have this data source block. We have this resource block. Let's understand what is this resource block is. Now we are clear about the provider block, right? Now let's see what is this resource block. Okay. This is the provider configurations. Okay, resources. Resources are the most important element in Terraform language. Each resource block describes one or more infrastructure objects, such as virtual networks, compute infrastructure. So this is the most important element, right? If you're going to a hotel to eat something, right, restaurant, you have to choose from the menu what food you want, right? Similarly, if you're going to the infrastructure, what resource you want, you have to choose. Very simple. Now, so resource is the most important element. Now, if you're going to a restaurant, so food will be your most important element. That is what you're going to eat it, right? So to use and select the resources, you have to use the resource block. How you'll use, that is what I was showing you here. So you have to select this resource block from this left side bar, go to the resource section here. Suppose you want to create one EC2 instances, or you want to create any AMI. What is AMI? Amazon machine image, an image file. So you have to go to Amazon. Suppose I'm going with EC2 instance creation, right? So what I can do, I can just go ahead and use this AWS instance resource. This is the resource name. So you'll get questions in the interview also. What is the resource name to create the instances? If they are asking some silly questions, very basic questions, they can say AWS underscore instance. But see, again, the same time, we cannot remember all the resources name until unless you work frequently, right? If you're working very rarely, once or twice to write the code and all, you'll hardly remember few of the resources, not all the resource names, right? So if suppose I'm going to create the instances, so see, most of the instances, most of the resources we are going to see in our projects, in our upcoming demos, right? We are going to do lots of demos, lots of things, right? All these, not all these, few of them we are going to see it. Now, so this is only about the EC2 instances to create. There are hundreds of other resources available here. See, hundreds of other resources. So for each resources, there will be different resource blocks, resource names. So it will be more than thousands resource names, right? So, okay. Now let's go out to the EC2 Elastic Compute Cloud here. Go to this instances, click on this. And here it gives you the example how you use it. And here it gives it this particular AWS instances resource name, and this allows instances to be created, updated, and deleted. So it's also called the server provisioning, right? To provision a server, to update a server, to create, delete a server, right? Create, update, and destroy. These are the things you can do using this AWS instance. Now, here, leave about these data sections. We'll talk about the data sections later, right? Let's leave about. Now, let's go ahead and see about this one. See, here it is using another resource, AWS underscore BPC, AWS underscore BPC. And here it is using AWS underscore subnet. Now let's focus on very simple part. In our case, it is resource AWS underscore instance. This is what we are going to use it, right? For that, what we need very basic two stops. We need very basic two stops. Let's copy this particular part here. Okay, let's copy this particular part, resource part. Here. Paste it here. Let me explain you this. So what is this? This is the resource block. This is the provider block. Now this resource block, and we have the resource name. First, see how you have to write the syntax is resource block starts with resource keyword, and within double quote, you have to provide which resource you want to create, what resource you want to use it. I'm going to use AWS underscore instance to create the or update or destroy the instances. So you have to use this one. This is the resource name. After that, this is the just name you are going to use for that particular service. Okay, for that particular resource. This is the resource. This is the resource name, and this is a just simple giving a name to this to use this resource. This is the resource block name. Okay. Now let's delete this. I can just give us my instance, something like this, my instance. Now you have to choose the AMI. So as you guys know, right, whenever we create EC2 instances, first what we select the AMI, right? We select the imagine machine image to create one instance. So how we'll get this instance AMI? Let's go to the instances, or here we have this AMI sections, right? Just go to this image. We have this AMI. We have this AMI catalog, right? Click on this AMI catalog, and here we can search for which AMI. Suppose you are going to use this Imagine EMIs, right? So this is free tier eligible, this EMI, right? So what I can do, suppose I am going to use this particular EMI to create the instance. So here I'm selecting this AMI manually. I'll also show you how automatically you can create or filter the AMI from the AWS resources, from the AWS providers, right? From AWS provider, how we can select the AMIs automatically. No need to come here and select, right? For the time being, let me select, and this is how you have to get AMI here manually. To get the AMI, go here, and suppose I'm just going to delete all this. Okay, I'm just going to delete all this. Put it here. Done, right? And here, instance type is nothing but your what type of instance you want. We already know, right? Whenever we create this, see here the instance types. What the instance type is? It provides what configurations of server do you need. When you go for to purchase a laptop, you have to first see for the configurations, right? Similarly, when you go for a server, you have to see for the configurations. So if I'm going to use T2 micro, I'm going to get one CPU, 1 GB of RAM or memory, and the storage will be externally, we'll add it, no problem. Okay. And here, if you want more CPU, more RAM or more memory, you can go with T2 2 extra large, T2 2x large, right? Suppose let's go with our free tier. I'm not going to pay much to them. Let's go to use this T2 micro, right? So this is how I'm just going to explain you here. But so you have to choose what particular instance type you need it, right? Let's go ahead and put T2 micro, it's already there. So, or if you need T2 large, T2 medium, T2 nano, whatever, you have to update it. Okay. Now our basic Terraform code has been written. See how simple it is to write. It's very easy, right? And very easy to remember also. What do you need? You need a Terraform block, you need a provider block, you need a resource block. That's all. We have few other blocks, data block, data source block, other blocks are there. We are going to see it shortly. And just you have to pass the as a variable and value. That's all, nothing else. Kind of a JSON file, right? But here we have to just assign it with equal symbol, right? So region, this one, that's all, guys. Nothing you have to write code. No code, nothing is there. But little complex code is there, which we are going to learn in the advanced sections. Okay. Now our code is ready. Now let's go ahead, save it. So done, save. Okay. Code is written. What we need, the first thing, when you write the code, you have to first initialize the environment, initialize the Terraform file, whatever you have written. So for that, you have to use the command called Terraform init. That's all, nothing. You don't have to pass the file name also. Simply Terraform init where the file is present. So our file is present in this particular folder. Go to this particular folder, okay, and execute this command. Just a second, I'm getting a call. Yeah. So what we have to do? We have to simply just use Terraform init to initialize the environment. Now let's hit enter. So what it will do, guys? It will see initializing the backend, initializing provider plugin. So we in the provider block we have given provider as AWS with this particular version, right? So what it is doing, it is just downloading AWS for us, and then it is installing on the system, installing this particular module to use this particular version, signed by Hasikoff, and Terraform has been successfully initialized. Before you execute, remember, before you execute any new Terraform code, you have to initialize must. And you get definitely questions, what is the flow of writing the code and executing the command? Okay, so the steps you have to first use. If you have written a new code, first you have to initialize it. So what the initialize stage, it does initialize the plugins, it download, install the plugins, provider plugins, which you are going to use. If you would have given Azure RM, what it will do, it will download the Azure RM plugin and install it for you. Okay, Azure RM plugin and install it for you, right? Now, so it has created, right? What do we do? Let's go, same folder, we have this EC2 instance. We have initialized. Next command is to Terraform plan. There are only 3-4 commands you have to use, not much. Okay, Terraform plan. Hit enter. So what this Terraform plan will do? Terraform plan will, based on the code we have written, it will plan the infrastructure. Before we are constructing a building, before we are constructing a house, what do? We go to an architect to design the building for you, right? To plan a building, plan a house for you. What sort of things you need? What's your requirement? What's your budget? What's your area? Everything he will calculate and give you a plan. Similarly, based on the code we have written, it just plan for us what we need. So if you just see for this planning, we have this particular image, going to use, this particular instance type we are going to use, right? And then the rest of things will be created after the apply. Now, basic sort of things is required to create the infrastructure. So we have given it everything. Now, after plan, what is such? We can use Terraform apply to execute the real. So if you're happy with this planning, right? If you're happy with this planning, that everything works fine and all the things, whatever is given here is appropriately the same requirement, whatever you have given, then what you can go ahead, you can just go and use Terraform apply, right? Hit Terraform apply. Then, so what it will do, it will connect to the system, to the AWS account with the user account, and then it will create a server for us, right? See, apply, now hit enter. Enter, yes. So what is doing it? It's just creating the AWS underscore instance, and the name of the resource block we had given is my instance here. It's just creating, just wait for a few seconds. So it will just go ahead and create. So we did not go to AWS account manually and created. What we did, we just wrote a code in Terraform and we are going to execute it. Okay, just hold on for a few seconds. It will create the server for us. Okay. See, it created quickly because it has only one resource block and a very one things we have written it here. So what it did? It just added one resources. Nothing changed, nothing destroyed. Three things this particular resource will do. It will create, modify, and delete, add, change, or destroy. So one server is added. If I go to my account, this particular here, right? If I go to this EC2 section here, we'll see one server will automatically get created. Let's go to the instances here. Okay, so what we'll see here, we'll have the server with the specifications we had given in the Terraform file is created. See, we have this particular server is created and it's initializing now. It's now initializing. So what we did, using the Terraform code, we provisioned a server. We provisioned a server, and this is the IP, public IP of this particular server. The public IP of this particular server, right? So now, if you just see here, this we created the server, fine, but how will access this server? Normally, what happened when we manually select a server, or create a server, what happened? If you remember, guys, we used to select the security group, right? The firewall. So basic default security group or the firewall will be open for 22 port to connect to the server. But here in this case, as we simply created the house, the building, the server, we don't have the key to enter inside. So we have to attach a key to it. We'll see in our next code. Okay. Now let's see, everything is created. We have given this particular image, right? Where this is the instance ID. Okay. So if I just, this is the instance ID, and here T2 instance, this is the instance type we give it, right? And this is the AMI, which we have given it here to create it, right? So what is it? This is the image, right? AMI 8B01. So AMI 8B0. This is the image ID used, right? Now, if I just go ahead and try to see if any security is given here. So the default security group is added. So default, if you don't select it, you can just see the default security group is added. So if I just go ahead with the default security group, let's see what are the port is whitelisted or opened. So what we say here, nothing is given. Nothing is given, right? So let's go ahead. Let's try to connect the server. We'll see whether we are able to connect the server or not. Okay. To connect the server, what we need? We need the key. So we have not attached any key or specified any key. So how we'll connect that? We cannot connect it. Also, the port 22 is also not opened, right? So we'll see these things in our upcoming code or upcoming demo. I'll add the key and security groups. Okay. Now we saw a server is created here and it's running. Now see, suppose you felt like I don't need this server to T2 micro. I need suppose something like T2 nano. So what you can do? Either you can manually change it, but it's not a good idea and good practice to manually do it. So what you have to do? You have to simply change the code, right? Suppose vi C2 instance. So go to the Terraform. Here, what you can do, you can simply, okay, before changing that, let me show you. When we execute this Terraform apply, right, we'll have this file created, the Terraform TF state, Terraform state file. So we have a separate, we have totally complete elaborated class on the TF state. I'll just explain you in detail. That is most important to understand the state of the Terraform. So that's a completely big class will be there, at least for half an hour or 1 hour, we explain about the TF state. So now remember, whatever the infrastructure we created, all the Terraform state details, everything will be stored here. All the details will be stored here, whatever we created, right? Now, just a little bit, you just get it some hint, but in detail, we'll learn about the TF state, okay? So here, if I just open this Terraform state file, see, it has the Terraform versions, everything, and about this provider, what is the AMI used, right? Instance, all the instance details, right? What is the AMI used? What is the ARN, Amazon resource notifications? Or here, the availability zone, which availability zone it is added, right? Same time, we can get all the details related to the server, okay? See, this is the instance ID, right? And see, instance type T2 micro, instance state is running, right? See, all these details, you'll find it here. Public IP, we'll see in details in advanced section how we'll fetch these informations from the Terraform TF state file. So this TF state file will be used for future usage, like for if you extract some data and feed it to some other application, you have to use this Terraform. And it has major other roles also. We'll learn is in details later in class, okay? Now you saw all the informations, whatever the server is created, everything, whatever data here, right? Whatever data, everything added in the Terraform state file. Okay, now this Terraform state file is having the instance type. If I just grab instance underscore type, Terraform TF state file. So we have this T2 micro, right? T2 micro is now given. Now let's do something here. Let's go ahead and change the, suppose I feel like I don't need this, I may need it T2 nano, right? So what I'll do here, I'll simply go ahead, go to instance type, okay, update from T2 micro to T2 nano here, T2 micro to T2 nano. Save this one, done. So here I just updated from T2 micro to T2 nano. Now, if I just go ahead and update the same thing, for that, I don't have to do initialize again, because we already, as I told, when you create the first Terraform file, you have to do Terraform init to initialize it, to download and install the provider plugin and all. Okay. But once you update something, you have to do first Terraform plan to plan the details, whatever changes, modifications to your house or infrastructure. Okay. If you feel like whatever modification you have done, it's approved, and you can go ahead and do direct construction, you can just go ahead with Terraform apply directly. No problem. It will just go ahead and create it. If you're 100% sure whatever changes you are doing is correct, right? So if not, then just use Terraform plan. Just wait for a few seconds here. What is doing here? What is Sage? This is what is going to be done here. So it's giving us the report, right? This will be updated, and from T2 micro to T2 nano. Okay. Now what we can do, use apply. So what will do? First, it will destroy. First, it will destroy the existing server. See what it's doing? It's just modifying. Okay, it's not destroying, it's just modifying it. So if I just go ahead and refresh this, okay, so what it did? First, it destroyed it. Okay, it stopped it. It not actually destroyed, it stopped it. It's stopping it. And then after stopping, what it's doing? It is modifying. Remember, guys, it will not destroy. It will stop the server and change the modifications. It's still doing, see, modifying. It's still modifying. We can see here, it stopped the server automatically. After that, what it will do? After stopping, it will do the modifications and then start the server. Normally, what do we do when we go for a house renovation, right? Renovating, what do? We remove everything from the house, all the persons or the belongings. Then we renovate the house and put it back, everything running, right? So same thing here it is being doing. So it's just stopping the server, just doing the changes, whatever is required, and then it will start the server. So what you can see here, okay, modifying, the modification is completed in after 52 seconds. See here, nothing added, only one changed, right? So if I just go ahead and refresh this thing, see, it's now running. It's now running and initializing. So we'll have this server created, IP address is created. Okay, so now clear, we have this server done and created. Now, if I just go ahead to the state file, so don't focus on the state file now. See what you can see here. Earlier, we had only one state file. See, in this folder, we had only TF state file. So when we did some changes to the Terraform file, what happened here? It just first took the back of the existing file, and then it did some changes and created another TF state file. So if I just do grep instance underscore type here with this Terraform backup file, let's see, it has T2 micro, right? If I do same thing for TF state, it has T2 nano. The TF state has T2 nano, right? This is the changes being done. We'll learn in details what is the usage of this too. Okay.
So this is for the rollback of to T2 micro again, the TF backup.
It's kind of yes. For a rollback, for other stops, we can use this backup file. Normally, as we know, right, for any changes, anything for the infrastructure, any server or anything, first we take the backup of that particular things, right? Then we did do some actions. If any changes required, we can roll back. But don't worry, we don't have to do anything from the backup here. That is for the informations we keep it. आज we are going to write this code in infrastructure as code, right? In tool. What do? We versionized these things. We keep it everything in the source code management, right? In the repository system. We don't have to roll back from here. We have to get that previous version. So suppose when I did some changes to T2 micro to T2 nano, the TF file is changed. Then we have to commit it to a new file in the GitHub or Git, right? Then if you need to roll back, then you have to get that particular version and do it here. So it is a very similar, simple, very basic, simple changes. So you don't need to do that. If there is just thousands of lines or hundreds of lines is written and what are multiple changes you have done, better you have to go and get it to the previous versions. And normally, even though you do small changes, if you are automating the stops, you should use the previous version of the from the repository, previous version of the Terraform file from the repository, and use it to recreate the previous server. Okay, and that it has different uses. We'll just learn later on. Okay. Now, so now we saw how to create it and modify and all these things. Now let's go ahead. So this server is suppose we feel our work is done and we don't need this server to be there. So we can use the command called destroy. Same code will be there, terraform destroy. Okay, hit enter. Just a second, guys. Wait. Okay, let me just hit enter. Okay, guys. So here we can see it has been destroyed now. See, one resources destroyed. So if I go here, just refresh it. See, it's terminated, right? The resource is now destroyed. The same time, if I go and check the TF state file, so it has now taken the backup. But if I see the Terraform state file, it has no data. So if I just search, open this file, see, it has just Terraform version informations, but no data available because everything is destroyed. But before destroying, it has taken the backup of the exit. Now, if you see in the backup, the instance type will be what it will be.
Nano.
Yes. So the current infrastructure information it will capture it before doing any modification or changes or destroying, right? So it will be nano. Now everything is clear until this so basics from the starting we just explained. I hope everything is very clear. Do you have any doubt, guys?
Ajay, if you want to create now we have created only one instance, right? So if you want to create multiple instance, so even that can be done using the code, right?
Yes. So this is what this is where we have to do the automations, right? If you are going to do single things, why automations you need? You don't need. You have to just write do the single simple small construction, small changes. You are then you can write a small code or something. You can directly go and create one instances. Automation is required if you're doing repeatedly tasks multiple times and more tasks. Then you have to go with the automation. Similarly, here we can create hundreds of servers, right? Using these automations. The same template can be used to create hundreds of codes, hundred of servers. So how we'll do? That we'll see in details with some kind of loopings and all, how we can create multiple servers with the same code and all. We'll see in the advanced everything. Okay, this is just the starting, right? We are just
Yeah.
seeing.
Okay.
Yeah. Now, so what we saw one resources we learned. Now let's see how we can give the key there and how we can use the security group resources to add the security group there. So to add the security group, what we have to use it with what resource? So you have to just go with AWS security group resources, which is here. If I just go to here, we'll have security group. Okay, let's go here, come down. We have security. Okay, so the security group will come under the VPC, okay, under the VPC virtual private cloud, we'll have these resources security group. Okay, see, we have this security group. Okay, suppose you don't know where to find it, so what you can do, search it here. Okay, search it here. Suppose security group, security underscore group, or security group, right? Okay. Now you can see which particular resource you need. If I go, I don't need this under VPC. You can see here we have this AWS security. So I need these particular resources. So as I said, there are hundreds of thousands of the resources available, so we cannot find it, right? Know it and remember it everything. So we can just search for here. We'll find this security group to use it. So the AWS security group. So here, the details, how you can use it, everything, all informations, the ingress and egress. So when we provide the security groups, right? Suppose if I go here, the security group here, we'll have the inbound and the outbound role, right? Inbound and outbound. Suppose if I click this particular one, we'll find here inbound rules and outbound rules. So inbound rules, like the traffics which can come into this server to connect to this server. Outbound is from this server where you are connecting. So similarly, the name, whatever in security group Terraform, it ingress and egress. Ingress and egress. Okay, this is the rules name. So how you'll write it? See, here is the simple, very simple format. No need to do anything. Simply go ahead and just copy it and put it there. It will be done for you. Okay, so what you can do, let's go ahead, copy these particular things. Okay, go there. PI is situ. Okay, now what you can do, same file, I'm going to add it here. Same file, I'm going to add it. But let's do some changes. So here, the another resource block. Here, two blocks I added. One block is AWS underscore instance. Another block is AWS underscore security group. Suppose I want to add some security group to this one. I just gave it here. Okay. So add a security group. Now, just use it whatever the VPC or whatever. So I just don't want this particular VPC ID or something. This name allow underscore TLS, let it be there. It's up to you what you want to change it. Now let's go ahead. As I don't have this main VPC sections available here, I can delete this particular things. Give ingress, outgress. So ingress, give the descriptions, up to you. If you want to give it, or else leave it. From port, which port you want to firewall open, right? So give that port here. Okay, give that port. Suppose I want for 22 port, right? Remove 22, and protocol for 22 is TCP. And the CIDR block, I can just give for 0, just copy it here. CIDR block, I don't need this IPv6, let's remove it. IPv4, I can just put it here, sorry. Put it here. So public access. I give 000, right? Now, and egress access outbound, you should give always the protocol is -1, and from port also 00 is not a problem. I'm not going to connect from this server to anywhere, so give it 0, no problem. I just given 22 ingress inbound. That's all. And after that, this sections it should be there: ingress, outgress, ingress, egress. Okay, and tag is just giving a tag, right? We have seen, right? Whenever creating some resources, we used to provide the tag. So you have to provide the tag there, right? Now we just have added this AWS security group there, one resource. Let's save it. Let's save it. We have done some changes. So as I said, any changes to the Terraform file, we can use Terraform plan, right? Or apply, you can directly do it, but just, sorry, Terraform, not from Terraform plan. Okay. So if the code is okay and there is no error, so it will just give us the plan details, right? Good. So it's just giving with security group to be added to this CIDR block and all, right? All this added. Now let's go ahead. Use Terraform apply. Terraform apply, right? Yes. So what is doing? First creating the security group here. See, allowed, yes. So creating the security group, and this is the security group ID. Okay. Just hold on for a few seconds. What, okay, so what we can see here, we have two resources added, right? Two resources added. One is the EC2 instances created, another is the security group created. Two resources we created. Now let's go ahead to the EC2 instances here and just verify. So we have the instances. Refresh it. See, one instances is created now, it is initializing. So if I just select it here, we have this and go to the security section. Here it's added. Okay, here it is still the default security group. Here still is the default security group attached. We have not attached any security group here, right? So how we'll do that? We created two resources, but it is not attached to here, right? Nothing is, default is attached, but our allowed TLS is not attached here, right? So what we can do, we can go ahead and attach this one. Let's search for AWS underscore instance. So see how we can add this security group here, right? So subnet ID and the sources. I'm just seeing some example. If it is there, it's okay. Otherwise, we'll see somewhere else. Okay. Security group. Control F, security. Okay. Here is the security group. So these are the, okay, let me just explain you these attributes. And okay, we have a different separate classes also there for understanding these attributes. Okay, arguments, this argument. So whatever this argument we use, right? What is this? If I just open this file, situ sections, here is the argument, right? For this particular resource, we used AMI. These are the, remember, these called arguments. Okay, these are the arguments, AMI These are argument reference. AMI, we can use what AMI is required, availability zone. We can still specify which availability zone we want our resources to be created, right? And then as we search for this, you can search for whatever argument you can use to that one, right? So let's go ahead, IPv4 and key name. I'll just go to this, okay, key name. Now what I need, we need this particular security group here, right? Security group. In this security group, and we can use security underscore groups, but no, if you are creating instances in a VPC, use VPC underscore security groups underscore IDs instead, right? Let's copy this particular thing. Okay. So where you have to add, as we created a security group here, let's add this one into the resource block of AWS underscore instance here, right? We need this instance to connect this one. How we'll do that? Let's go ahead here. Okay. Okay. Let's paste it here. Equal. 1 second, guys. So here you can see we have just added VPC underscore security underscore group underscore IDs equal to. Now let's give it here. What we need this particular name with this resource block with this allow. How we'll get this particular ID which is created by here. Now what we can do, we can just in the square bracket, we can provide AWS group here. Okay. Now dot allow TLS. We don't need this square bracket. Let's remove it. Put it here. Allow TLS. Okay. So we have to add this. Let's see if it is working. So what we did, we just added AWS underscore security group with this name. I'm going to get with this name, I'm going to get the security group ID attached to the AWS instance. Right? Now save it. Save. Let's plan. Directly apply. What it will do? Okay, it is throwing error. So AWS instance, this particular set of strings is required. So we need some set of strings. What I did. Okay, here's the problem. It should be quoted inside the square bracket, not outside. It's a typo. Let's remove this typo here and put it here and remove this. Done. Save it. Now let's apply. So what it will do, it will just modify it, right? Yes. Modifying network invalid group. AWS security group dot allow TLS does not exist. Why it is does not exist? AWS underscore security group dot allow TLS. Okay. C2 instances, the security group AWS allowed does not exist. Let's go ahead. Let's see this one. VPC. Okay, let's go to the security group part. There we'll find the security underscore groups. Go to the security groups. This is what you have to use it. VPC underscore security group test.id. Okay. So we have to use the ID option here. Okay. What is this ID? If I just go ahead and check, right? If I just go ahead to AWS underscore instance, this is how you have to work on, guys. Okay. You have to see lots of changes and lots of things to be there. I'm just showing you from the scratch how you have to use the documentations to find and write your code, right? So what we did here, we used the resource name, we used the name of the resource block, but we have to specify the ID. We specify the security group ID, right? So how we'll do that? If I just go here, we have one section is called argument reference. Same time, we have another one which is called, one second. These are the things we have, metadata sections. Okay, we have this attribute reference. There we saw the argument reference, argument, whatever the argument we want. And here we have the attribute sections. Here the attribute sections will find one ID. Okay, we'll find ID sections here. Okay, so what is this? ARN, the reference number, instance state. For that, for what instance state? This is for AWS instance. So we need for the security group, right? The ID of the security group. Suppose if I just go with the security group here, so here the security group will have security groups. Okay. Security group will have, if I just go to the attribute reference, we'll find, see, ID of the security group. Okay, we have to first give the see resource name here. First, what we give here? First, we gave the resource. Okay, let's remove this one. I don't, it's also not required, I believe. If required, then we'll put it. So, sorry. What we gave here? The resource name, this one, and the name of the block, and we have to provide the attribute here. Sorry. We have to provide the attribute here, ID. So it will generate the security group ID, name of the security group. Okay, ID. Now let's save it. Now apply, Terraform apply. Yes, it's working. Let's, yes. It's just modifying, let's see. See, it has done one changes. One changed. Now you saw how you have to use it, right? That is the very critical information you need to have with you all the time. You should know how to use the documentations and how to use those things to write your code, right? So now if I just go here, refresh this. Okay. So it's running and it's just modified the. So if I just go here to the security section, see, it was before default. Now it is given allow underscore TLS. So if I just see here allow underscore TLS, it will have port number 22C. Port number 22 is firewall. Only port number 22 is open to access. Now you saw how we attached we created a resources and attached to the AWS underscore instance resource block to add it into the resource. Now we have got this 22. Now let's see whether we can able to access it or not. But still we cannot able to access. Why, guys?
Because there is no key.
Exactly.
Yeah.
So we have not provided any key yet. Right? So what you can do here? So we don't have any key, right? So if I just go here, the key section here, see the key pair assigned at launch, none, nothing is there, right? So let's provide a key to connect the server. So what you'll do now, how you'll provide it? Let's go to the AWS underscore instance section here. Okay, and there search for the attribute name, which attribute we should use to connect the, like I search for the attribute name for security group, right? Similarly, you have to search for the attribute name for the key name, right? So let's go to the attribute section here. It will be my underscore key. It should be key name. Sorry, key underscore name. It will be key underscore name here. Key underscore name. Or you can use AWS underscore key underscore pair, which can be managed using key pair for the, this is the resource block. But you have to use the key name. Which key name you have to use it. Okay, fine. Now what do you need? The key name. So just provide a key name. Let's modify the Terraform file. Okay, so the key name we have to use it here, right? Key underscore name equal to provide, suppose star dot pay, right? This is the key name which is available there, right? So how will find whether which key is available? So you have to go here, right? Go the section here, and the key is available, right? You can just key pairs, network section key pairs. So you can see I have only one key. The key name is available, right? So I'm going to use third.pem file, right? So if I go here, just use this key file here. This key name will be used. Let's go ahead and save it. After that, let's apply. Okay, it will just modify and see these are the changes. Is not required the server to be stopped. It is not stopping the server, right? It's just modifying it. Okay, it's just okay. But here in this case, what it did, see, for security group, it did not do anything, simply changed it. But for adding this key, what it did, it destroyed first. It's terminated the server. Be careful if you are changing anything like this. Make sure you took all the required backup of the server and then add the keys. Otherwise, what it will do, it will destroy your server. Now your server would have terminated, right? If I just go ahead and search for the instances, here this, see, terminated. After terminated, what it do, it will just recreate it. It will recreate it. Okay, but creating, it failed. During creation, it failed. Third.pem does not exist. Invalid key pair not found. Fine. So let's modify the code. Code is required to be modified. So key pair name, key name, third.pem is not there. Okay, should be there, right? Why it is not? Okay, so what we can do here, I can just copy it, right? Downloads, pem to this one. Okay, so that this certificate file is copied now. Let's execute, apply. That is why it is saying that it does not exist, right? Yes. What it says, pem dot file is not invalid, key pair not found. The key pair is not found. Okay, let's go here. The key name, what it was given again, the key name of the key pair to use the instance, which can be managed using the key pair, right? Let's go to the key pair resources. This is the key pair to generate the key, but I already have the key available, but it's not taking. The argument is the key name. Okay, fine. So here, okay. So key name is not available here. Terraform Okay, let me get 1 second, guys. Hold on. I have just a Terraform file in my project, so I can get the code there. What was the code was written there? What is the key was written there? Okay. Terraform log functions. Terraform. Twitter architecture. This is the project I'm going to give you. Don't use it now. Okay. It's a big project. I'm going to use it. Oh, okay. It's my mistake here. So what we have to use? Not the PEM name. Sorry. We should not use the PEM because see, I was showing you, right? If I just see here, it's my mistake here. If I just go to the key pair section, the name is third, not third.pem. I did a mistake here, right? So what you have to do, we have to just use third, not third.pem here. Okay. Just remove this .pm from here. Remove the .pem from here. Save this one now. Done. Now, what we can do, simply Terraform apply. Terraform apply. What will happen? Just wait for a few seconds. So what we can see here, it's one resource is added, right? Now let's go ahead. Go to the instances here. So it started running now. With T2 Nano, guys, make sure that you change to T2 Micro, okay? T2 Nano will charge you. It's not on the free tier, right? So use T2 Micro. Okay, I have not modified it, so it's still T2 Nano here. So you can see here, if I go and select this particular things, this particular running, right? So our security group is added, allow TLS. But if I go to the key pair section, right? See, the key pair assigned is third. The key pair assigned is third here. Okay, so what we can do here, let's go ahead, use the command SSH, right? Hyphen I, the key here, third.pem, and EC2 hyphen user. This is a Mac and Linux, right? And provide the IP address. Let's see whether we are able to connect or not. Copy. Paste it here. Hit enter. Yes. Good. See, now what we can see, we can able to connect to the server also. So what changes we did? What changes we did? If I just go here, we'll have this key pair things added, right? This key pair, third, we added this security group. These two things is required to be added into the instance section. So guys, we did lots of things today in the first class itself from the basic. So you guys, I'm not going to stretch more on that to give more details, complete details. So what you do today, you just do practice whatever we have done, starting from just installations and just overview on this, and just go through what is the provider, how to use it, do small example of creating the server and adding it. So whatever just we did it, right? The same things we just work on. Okay, and in our tomorrow classes we'll go little more advanced. See guys, everything whatever I'm going to tell you will be hands-on, whatever I did today, right? Same thing, everything, only the discussions about that particular theoretical things, what is that and all, how to use it, and the rest of the things we have to write the code. So the first class is over, and we have another next 3 classes. Within these 3 classes we'll try to cover out this Terraform. So every day we'll have this 2 hours of the classes. Okay, that's all guys for today's classes. Just use it. Okay, before that, let me first destroy it, right? What we can do, we can just use it. Terraform. What is the command?
Destroy.
Terraform destroy, right? Terraform destroy, which enter. So what it will do, it will destroy one after another for two resources created, right? One is the security group, another one is the instances.
Instance.
These two resources it will destroy one after another. But one more interesting thing I'll tell you guys. Just hold on a few seconds. Okay, one more interesting thing. Now let it destroy. Okay, let it destroy. I'll tell you what you saw here. I have just simply written only one file. I have simply written only one file. Okay, as we already have closed this session, so let's keep it that one to our next class, maybe tomorrow classes. Instead of keeping this in one file, we can segregate all this into different simple sort small files, like I have done this in this project, right? Like I have done in this project. See here, okay, let's open this one. You can see here I have simple EC2, EIF, all these TF files, small TF files. Okay, and provider block also have small TF file, and this provider block does not have anything related to the keys and all, right? So in tomorrow classes we'll talk about this. Don't go with these things, you will not understand much more. Leave it. We'll have this project when we finish this Terra. Okay, so so tomorrow classes we'll segregate using the segregation semantic. We say it's semantic, that we'll see it in tomorrow classes. Also, we'll see how we can hide the key, right? How we can hide the key. Here we have the key, right? A plain key we have given it. Tomorrow we'll see how we can hide this key. We don't have to put it here. We'll save it, and also we can and also we can segregate this resources, one resource, two resource, and provider block into two and separate different files, and we see how we can execute those things. Okay, that's all, guys. And make sure after you create, you use destroy command to destroy it, otherwise they will charge you. Okay, now another things I'm going to do it is when it's created, right? What we can do, simply let's first change this nano.
Here protocol section mentioned -1. What is -1?
Yes, I'll just give you. Let's choose you.
Here
So
egress.
here the protocol is -1, right? So what is this?
Yes.
The protocol we use TCP. So here we
TCP.
can see here we are not using anything. Egress is totally blank. So we are not going to use anything, right? So we should
Yes.
why should we give any protocol name? Simply given -1. Nothing will be there added. Okay.
-1 means nothing.
Yeah, it will be nothing there. If I just
Okay,
go
okay.
ahead and check any existing system here running, right? Anyway, it's not running. So anything anyway, it is destroyed, right? Let's go to the
Yes.
security group. Here I have this inbound rules, right? This protocol is given like all. Similarly, -1 will be all protocols. So nothing will be no specific protocols. It will not given no specific protocols. If I go to the inbound rules, it will have specific protocols, right? You have to specify like this.
Yes.
Okay.
Yes.
Yeah. Okay. That's all, guys, for today's class. And we'll just see it and tomorrow. We'll see the other things and one more thing. What I forget. Okay, fine. We'll see tomorrow. Okay, let's stop this.